Hello students, welcome to chemistry classes. Today under this hydrogen lesson we are going to discuss one important compound of hydrogen called water. So far we discuss various topics in the hydrogen lesson. Now water is one of the important component of or compound of hydrogen. So we know that what are the importance of water. Without water there will be no life. All the living organisms, either plants or animals, must utilize water for all biological process, biochemical process, etc. In our body 65% water molecules are present. Due to the presence of water molecule only the biological process or takes place without any difficulties. So water plays an important role. It acts as a solvent for majority of ionic compounds, even some covalent compounds. Majority of the ionic compounds are soluble in water. Therefore, water acts as a universal solvent. Even these covalent compounds like methyl alcohol and ethyl alcohol readily soluble in water. So water sources, we know the water sources. Ocean is the major source of water, and fresh water is obtained from some other small streams as well as wells, etc. Okay. Now what are the structure of water molecules? That is very important in the examination point of view. What is the structure of water molecule? We know that the molecular formula for water, the formula for water is H2O. It consists of two hydrogen atom, one oxygen atom. Oxygen atomic number 8, electronic configuration 1s2, 2s2, 2px2, 2py2, 2pz1, or 1s2, 2s2, 2px, 2py, 2pz. So this is the configuration 2px2, 2py1, 2pz1. It consists of two unpaired electrons, unpaired or bond pair electrons, and the valence shell consists of two lone pair electrons, We must know that these bond pair electrons bonded with two hydrogen atoms. Bond pair electrons bonded with two hydrogen atom, electrons of two hydrogen atom, to form the bond like this, OH and H, OH. These two lone pair electrons present in the oxygen atom. Therefore, oxygen becomes more electronegative. It partially polarized, delta positive, delta negative. Here also delta positive, delta negative. The interaction is called dipole interaction. Dipole interaction. Normally, considering the two lone pair of electrons, the oxygen water molecule is drawn like this, H, one of the p orbital. It consists of lone pair of electrons. Normally, it shows the tetrahedral. It having this tetrahedral arrangement, but due to this lone pair repulsion, the molecule is in the bend shape. Shape of the water molecule in the gaseous state is bend shape. The bond angle is 104.5 degree. And it shows greater dipole moment value. Dipole moment value is equal to 1.54 d by dipole moment. It shows the dipole moment value, and it shows high dielectric point. water source high dielectric point. And this is the actual structure of this molecule. Normally it is written like this, HOH, this oxygen containing 2 lone pair of electrons. And the water exists as another one state is called this ice. Water exists in the form of ice. What is the structure of ice? Listen, this oxygen molecule, this hydrogen, and this oxygen is bonded with bonded with the hydrogen atom of another one water molecule. This is 2 water molecules. This chain will continues like this. Here also O and H. So it leads to tetrahedral arrangement, and this part is called vacant space. Vacant space, or otherwise known as void space. Void means empty space, does not having any components present inside the cavities. And the normal structure of water is like this in the gaseous state, HOH, etc. So this is one of the arrangement of atoms in the water molecules. So now we are going to discuss the physical and chemical properties of water. We know that water is a liquid and its freezing point is 0 degrees Celsius, and the boiling point is approximately 100 degrees Celsius or 100.2 degrees Celsius. Especially 100 degrees Celsius is the exact boiling point of water. And maximum density of 1 gram per centimeter at 227 Kelvin. One maximum density is 1 at 227 Kelvin or 4 degrees Celsius. And water has strong hydrogen bonding. Water exists in the liquid state is due to strong intermolecular hydrogen bonding. Water is a polar in nature. I already told you water is a polar in nature. It provides partial positive charge as well as partial negative charge. Therefore, majority of the ionic compounds are soluble in water. Hence, it acts as a universal solvent. And now some chemical properties of water. Chemical reactions of water. First of all, the stability of water. Water is stable at ordinary temperature as well as at a very high temperature. When it is heated extremely high temperature of about 1500 Kelvin, water dissociative provides. Water in the gaseous state heated at 1500 Kelvin, it gives hydrogen gas and oxygen gas. So stability, water is stable under normal temperature and extremely high temperature. Even both 1500 Kelvin only it partially dissociate. Here also only 2% of water molecules only dissociate at this temperature. So it is highly stable. Acid base characters. Acid base character, it behaves as acid and base. It behaves as acid at one time and bases at one time. Therefore, water molecule is exists as amphoteric nature. Amphoteric nature of water molecule. So we know that this water molecule H2O partially ionized provides H plus and OH minus ion. This H plus combines with another molecule of water gives hydronium ion. Combining these two equations, 2 molecule of water on dissociation gives H3O plus ion and OH minus ion. The Kw of water, ionic product of water at 25 degrees Celsius is 1 into 10 to the power minus 14 mole square liter raised to minus 2. Kw means ionic product of water, the value is 1 into 10 to the power minus 14 mole square per liter square. This is the stability as well as amphoteric nature of water. Amphoteric nature means it reacts with acid as well as the bases. For example, it behaves as base towards hydrochloric acid or hydrogen sulfide. Suppose it reacts with hydrochloric acid, and it provides H plus ion, hydrochloric acid and water, H plus ion, or H3O plus ion, H plus or H3O plus ion and Cl minus ion, H plus or H3O plus ion and Cl minus ion. And bases, water reacts with ammonia is a base, it provides NH4 plus ion and OH minus ion, NH4 plus ion and OH minus ion. So, hence it behaves as acid as well as base. For example, H2O is the first part liquid, H2O is a liquid at the second part, this is acid 1, this is base 1 or base 2. It ionizes, provides H plus or H3O plus ion and OH minus ion. This is acid 2, this is base 1. This can be explained according to the Lewis concept of acid and bases. Lewis concept of acid and bases. The next is oxidizing as well as reducing agent. Water acts as a oxidizing agent as well as reducing agent. The better example for oxidizing agent, sodium. Sodium reacts with water. I already explained in the previous classes the electropositive metals like sodium. Sodium reacts with water, it provides sodium hydroxide and hydrogen is liberated, hydrogen gas is liberated. Sodium reacts with water, gives sodium hydroxide and hydrogen is liberated. So, it acts as a oxidizing agent. For this reaction, it acts as a oxidizing agent. In the case of carbon, carbon reacts with water, gives carbon monoxide and hydrogen. So, this last class we discussed, this is the syngas, synthesized gas or syngas. This is the oxidizing agent. In these two reactions, this hydrogen as water acts as a oxidizing agent. As a reducing agent, as we know that reducing agent, fluorines, electronegative metal elements such as fluorine. Fluorine reacts with water, it readily decomposes ozone. Fluorine reacts with cold water, it gives ozone. So, in this reaction, water acts as a reducing agent. O3, HF, O3 and HF. Water reacts with the fluorine, it gives O3. O3 is the ozone, is produced during the course of the process. Therefore, it acts as a reducing agent. So, another better example, we know that the photosynthesis process, green plants prepare their own food with the help of sunlight and chlorophyll, the carbon dioxide and water molecules. Carbon dioxide and water molecules, this water molecule is converted to oxygen. Water molecule is converted to oxygen. So, for this photosynthesis process, this water acts as a reducing agent. Water acts as a reducing agent. And similar way, hydrolysis reactions. Hydrolysis reaction, metals hydrolysis, sodium, calcium and other metal atoms reacts with water, provides corresponding hydroxides. Sodium reacts with water, gives sodium hydroxide, and oxide form of the metals, calcium oxide. Calcium oxide reacts with water, gives calcium hydroxide. Magnesium oxide reacts with water, gives magnesium hydroxide. Sulfur trioxide reacts with water, gives sulfuric acid. So, for all this hydrolysis reaction takes place. And the last one is hydration reaction. Water form better addition compounds with salts. Better addition compounds with salts. For example, barium chloride, 2 molecules of water. Copper sulfate, pentahydrate. In this copper sulfate pentahydrate, this water forms the coordination compound with copper. Cu H2O 4 times, SO4 dot H2O. Tetra aqua copper 2 sulfate. Tetra aqua copper 2 sulfate. Monohydrate. Monohydrate is a coordination compounds, tetra aqua copper 2 sulfate monohydrate. So, these 4 molecules of water utilized for the complex formation with copper. And similar way, chromium, hexa aqua chromium 3 chloride. The name of the compound is hexa aqua chromium 3 chloride. Hexa aqua nickel nickel sulfate, SO4 nickel sulfate. So, these are the hydration compounds formed with metal salts with water. So, I hope all these concepts are understood by each and every people. If you have any doubts, you may ask. You completely go through the books and write the equations and practice very well. Thank you.